Okay, let me continue with a couple more applications. We'll just throw a couple geometric problems into the mix and see how quadratic equations can come around there. So let's take a look at this first one, which is an area problem. I need to know the length and width of this rectangle, and I'm given an area of 50 centimeters squared. So we know that area is equal to length times width. Area is equal to length times width. So now I'm going to say that is equal to x plus 5 times x, which I could multiply through to give me x squared plus 5x. And because we know the area is 50 centimeters squared, I'm going to set this equal to 50. And here is the equation that we're looking to solve. So I'm going to try to use factoring to solve this. So let's subtract 50 from both sides. I'll just kind of put it here in the middle. It doesn't go with either of those. But that gives me, let me write it over here, x squared plus 5x minus 50 equals 0. Let's attempt to factor this negative 50. And it appears that 10 times negative 5 are excellent numbers. They add up to 5. So that means that this factors to x plus 10 times x minus 5. All of that is equal to 0. Then I can use the zero product principle or property to say that x plus 10 equals 0, or x minus 5 equals 0, giving two solutions. One is x equals negative 10. The other one is x equals 5. Now remember, since we're talking about a physical problem here, we have to double check and see if these make any sense. If I had x equals negative 10, then that means the width would be negative, so that doesn't work. This is an extraneous solution. It must be that x is equal to 5, which means the width is equal to 5 centimeters. And the length is equal to x plus 5. So 5 plus 5 is 10. The length is equal to 10 centimeters. They're both positive. When I multiply them, I get 50 centimeters squared. So that is the solution. It checks out. Suppose we had a problem involving a right triangle. Well, in this case, we can say or invoke Pythagorean theorem. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. A and b, those are the lengths here that have a right angle with respect to each other, and they can be switched in this equation, but c always has to be this longest distance, which we call the hypotenuse. So if I invoke Pythagorean theorem here, I can say x minus 4 times x minus 3, x minus 4 squared. Ooh. Let's erase this. X minus 4. Give you some sound to go along with that. Squared plus x minus 3 squared is equal to 25, which is 5 squared on the other side. So I'm going to have to do a little work here. I'm going to have to square this out and then proceed. So if I square x minus 4, remember from the perfect square trinomial, what you should end up with is the following. I'll do this in blue. X squared minus 8x plus 16. I'm going directly to the trinomial using the perfect square trinomial idea. The next one becomes plus, I'm running out of space, x squared minus 6x plus 9. Okay, and all that is still equal to 25. Now I'm going to combine like terms. This gives me 2x squared. Negative 8x minus 6x is minus 14x. 16 plus 9 is plus 25. Still equal to 25 over here. I'm going to try to solve by factoring, so let's subtract 25 from both sides. And this gives me 2x squared minus 14x is equal to 0. There's a greatest common factor that I can factor out, the 2x, and I'm left with x minus 7 equals 0, which tells me that 2x is equal to 0, or x minus 7 is equal to 0. The left equation, if I divide both sides by 2, I end up with x equals 0. The right equation, I'm going to start by adding 7 to both sides. That gives me x equals 7. And I need to ask myself just a physical check, a dimensional check for this problem. X equals 0 doesn't quite make sense, because if I put a 0 here, that means this bottom length is negative. The same thing with the height. So this one, x equals 0, is extraneous. The physical solution must be centimeters, and since we had inches over here, we're talking about inches here, but that's just for the x. That's not the base and the height of the triangle. But I can use that 7 to say that the base must be 7 minus 4, which is 3 inches. And the height must be 7 minus 3, which is 4 inches. And this is the solution to this geometric application. How can I check it? I can use my base and height in the Pythagorean theorem. 3 squared plus 4 squared, does that equal 5 squared? And verify it for yourself. Indeed it does. So this is the solution to this application.